Okay, so today I'm going to be talking about how to determine the reaction order off of a chart or a table. So here we have a chart or a table, and we're going to look and determine the orders of un reactant A and reactant B. So to determine the reaction order of reactant A, I'm going to look at trial 1 and trial 3 because there's a distinct doubling of concentration of A and concentration B, and B stays the same. So I'm going to set it up to look like this. So I want the concentration of the third trial over the concentration of the first trial, and the rate over the rate. So looking at the concentrations, I have the concentration of A3 is 0.1 or 1.00, and then on trial 1 it's 0.5, and then the rate is 0.500 times 10 to the negative second, 0.50 times 10 to the negative second. So now I have this. So now I'm going to reduce each fraction. So this is 2, and this is 1. And then I put an exponent over here on the concentration side. So 2 raised to what power equals that? And I guess this should actually be an m, because this is going to determine the order. So 2 to the 0 power would equal 1. So we know that m equals 0. So A is to the 0 order. Now let's look at B. We're going to do this the same way, and then I'll show you a little trick. So for B, once again, looking at it, I'm going to look for when does this change. So from here to here it doubles, but the concentration of A also changes, so I can't use that. So here we'll take this 0.4 and 0.6. This changes, this stays the same. So we could use trial 1 or trial 4. We'll use trial 4 and then trial 5. So we have the concentration of B in the 5th trial over the concentration of B in the 4th trial. We always want to set the bigger one on top. It's going to make fractions easier. And then the rate of 5 over the rate of 4. So now let's actually set that up with numbers. So concentration of B in 5 is 0.6. The concentration of B4 is 0.4. This equals the rate in 5 is 1.5 times 10 to the negative second. And then this is 1 times 10 to the negative second. So then I divide these. So 0.6 divided by 0.4 is 1.5. And I'm going to put my m here, or my n here for concentration B. And then I'm going to divide these. So 1.5 times 10 to the negative second divided by 1.0 times 10 to the negative second. Hit enter, and I also get 1.5. So 1.5 raised to the n power gets me 1.5. So m is going to equal 1, because 1.5 raised to the first power is itself. So I know that B is in the first order. And so for A, I could have determined that just by looking at the graph here, because I see a doubling here, and then I see nothing happening to the reaction rate, so you didn't even have to do that math. You can just look at it and do that. B, you probably have to do the math, because looking at this and being like, oh, okay, it went from, you could look at 1 here, and be, okay, it went up by a factor of 3, and from reaction 1 to 5, it went up by a factor of 3, and so because those are the same, it's a first order reaction. That's how you could look at it based off of a table 2. I hope that was helpful.